All right, psychology nerds, and welcome to another episode of Psychology and Stuff, the podcast from Good Cause Productions at the University of Wisconsin in Green Bay. I'm your host, Alison Jane Martin-Gano, and today we are joined by Dr. Tom Crawford, better known as Tom Rocks Maths. Tom is a mathematician who holds positions at both the University of Oxford and the University of Cambridge in the UK. In addition to his academic work, Tom is committed to making mathematics engaging and accessible to everyone via his YouTube channel and other social media. He's here to talk with me today about how anyone can become a maths person. Hi, Tom. I really appreciate you coming on the show. Thank you so much.
Yeah, my pleasure. My pleasure. It's been a while, right? So
It has. It has. Yeah. So listeners, Tom and I went to high school together back in, when did we graduate? 2006? No, that can't be right.
yes,
Is that right?
no, it was 2006. Yeah. When we did GCSEs, right? That's when we would have left.
Yes.
Bridgewater
Absolutely.
High.
Bridgewater High, Miss Candola's maths class, which obviously you must have done really well in, was not my strongest class.
I was about to say, I seem to recall you were also pretty good at maths and all of the other subjects. Like, let's not.
I appreciate the compliment. Thank you. I always thought that with maths, I was getting to the edge of about how far my knowledge could go, and it was sort of realizing that at the end of high school, I was getting to sort of the limits of things are starting to just not be understandable for me, which is why I then went elsewhere with my studies. But you must have really kept loving it.
Yeah, I mean, I loved it then. I don't know if this came across to you as someone else in the classroom, but it's always been my favorite subject. It's one of them where when we were deciding what to do at A level, so when you make that choice, in the UK, when you pick just the 4 subjects to do from 16 to 18, for me, it was like, well, I'm obviously doing double maths. And then I just had to pick the other 2. And then at university, it was like, well, I'm obviously doing maths. Like there just wasn't, for me, there was never a choice. It was just maths is available. So that is what I'm doing.
Yeah. Okay. So we're definitely a different kind of experience. If maths was a requirement for me, and I did drop it at 16 when we left school, and picked up some social sciences. So you've always known that you loved it. So I'm curious, when did you shift from knowing you wanted to study maths and do research in maths to knowing that you wanted to talk about it on podcasts?
Yeah, that's a great question. I don't think it was a specific moment. I think it was a whole host of things, as these things often are, right? It's the smaller little interactions, and then suddenly it kind of, you're doing this thing, and this is now your career and your life, in the best possible way. So some of the things that come to mind, for example, when I was doing my undergraduate degree, so I was based here in Oxford for my undergrad, and in my second year, I joined an outreach organization, like student-led, called Marcus's Marvelous Mathematicians. Quite the name. M cubed for short.
Okay.
And we worked with a mathematician called Marcus de Soto. He's a professor of maths here in Oxford, and he is the professor for the public understanding of science, a very cool role at the university, previously held by Richard Dawkins. Very sort of big, famous people have this role. Yeah. And he got so many requests to visit schools that they set up this kind of student group. He trained us to do his talks based around his books and his content. And then we went out to the local schools and ran these sessions. So I think looking back, age 19 or so, I think that was my first taste of like how fun it is to take my enjoyment and enthusiasm for the subject and go and kind of spread it around. So like I did that for like a year, and then I got distracted by other things. But then I feel like, I don't know, I feel like just it always kind of remained in my head as something. So then like later on during the PhD, and then after that, with my actual now full-time position, I think that was like the first taster, perhaps, going back to being an undergrad, that's, gave me that little dip my toes in the water. I was like, this, that's always been something, a good experience I had, and something that I think I'd like to come back to that. And then that's kind of perhaps how it happened.
Yeah. So a little bit of serendipity there of accidentally falling on it in your first year, it sounds like, at Oxford. Yeah. Wow. Yeah. I feel
but
sometimes...
also,
no, go ahead.
I was going to say, but also accidental, yes, in maybe realizing or not realizing it would lead me to my career. But also I think I was drawn to the fact that I felt like it would be a fun thing to do. Obviously, there was, as an undergraduate student, there are a million things you can do, and one of them is your degree. But like, like in that, but so something was drawing me to, I don't quite know what it was because I can't remember what I was thinking yesterday, never mind 16 years ago. But like something about going out and helping other people discover maths in the way that I see it. Something must have drawn me into that, I think. But as you say, possibly then accidental that it led me to my career. But
no, but it does sound like there was something in you that was drawn to speaking to the public and communicating maths. I'm going to struggle between math and maths this whole conversation. So you'll hear both of those.
That's okay. I will always use an S. You feel free to use whatever feels most natural.
Yeah, it's totally fair. I'm just going to be bilingual, and I think the English is already coming out a little bit already.
Yes, so I am noticing.
It'll get thicker and thicker as we go through the podcast, and then the introductions will sound really strange. I do want to sort of talk about what it is that you do now. So could you just sort of summarize for the listeners in your sort of short elevator pitch, what is it you do to communicate maths at the moment?
Yeah, okay, I'll try. I would say, so my formal role, I'm the public engagement lead at the Department for Continuing Education, or we've just rebranded as Oxford Lifelong Learning.
That sounds better.
Yes, I agree. Yeah, it does, doesn't it? That's the catchy marketing rebrand. So Oxford Lifelong Learning. But it's like, I think in the US in particular, these are often referred to as extension schools. I think is perhaps what some of the listeners may know them as. So I do a lot of work there with promoting further study of maths for people who perhaps have jobs and want to study a bit in their evenings or weekends. A lot of work where I'm going out into schools and getting students to think about going on and doing a maths degree, or perhaps maybe a full degree isn't quite right for them. So it's thinking about other ways they can engage with maths through, for example, our department. And a lot of that work is kind of centered on, or my profile, let's say, has been built around social media, YouTube in particular. So my channel, Tom Rocks Maths, I'm approaching 250,000 subscribers, and I just went through 30 million views, which is crazy. That's like half of the UK. I mean, it's just a crazy number. Like, it's a number I can't get my head around.
And do you find most of the listeners are from the UK, or some of them from around the world?
There's a range. So it's definitely UK, US dominated. I think UK is the number one audience, and then US not too far behind. But then it varies because I do a series. My most popular video series is I take high school maths exams from around the world, but I do them like blind. So blind in the sense of I'm like, right, today we're doing this exam from Turkey. I have never looked at the paper. I turn my camera on, I open the paper, and I'm like, well, let's do some maths. And then I spend 2 hours trying to figure out how to solve these problems. So it's blind in the sense. No, that would be a challenge. No, it's translated. Okay. I have definitely used, sometimes I have friends who translate for me. Sometimes I just use, a translation tool, but it's blind. Really it's blind in the sense that I don't know the syllabus. I don't really know what to expect. So of course I know maths, but there are lots of like specific things. And it's part of the fun, I think, for me at least doing it, is trying to remember these things or unpack and be like, well, I don't know this particular theorem or this result they want me to use, but I know how to think things through. So can I like derive it for myself? So anyway, to come back to your original question, because I do all these different countries, I get these like spikes. So when I released the Turkey exam, like, half of my viewers that month were literally from Turkey, which was previously never in the top 10. And then I did a German one a few years ago, saw a huge spike in the German audience. So it's really fun because I think it means I can reach, I've sort of accidentally found a method of reaching a much wider audience than just necessarily the English speaking world, which would typically be my audience given it's all in English and it's on YouTube.
Yeah. Oh, that's fantastic. I'm going to have to go and watch some of those. Did you do any from our old high school exams? Have you redone the 2006
Of course I did. So I haven't done the one that we did, but that would be quite fun, actually. I think at some point I will go back and do the actual exams I sat. So GCSE
and see
2006,
if you get a better
A-level
score
2008. Yeah. No way. So this is the thing. I don't get full marks. I do very well, like, as I should, but I do not get full marks in any of them. No, there was one. I got full marks in the SAT. Yeah. The American SAT was the only one I got full marks in, just the maths section. but I don't on any of the others. So the GCSE one, that was actually harder than A level for me
Huh.
because A well, because at A level you do when you're 18, so it's closer to what I'm now teaching my first year undergraduates.
I see.
So it's kind of fresher in my mind. Whereas the stuff you do at GCSE when you're 16, like there was a question, all my audience laugh about this all the time. I can't do circle theorems. So when you have circles and lines drawn through them and certain angles are equal, it's like a
Uh-huh.
geometry thing. I don't know if you remember, there were three or four
Vaguely
key
remember
circle theorems.
geometry. Yeah.
Yeah. And I'm just like looking at it and it's like I have no idea. And then I mark it at the end and the answer is like, it's like a one-liner saying by the alternate segment theorem, this is the and I'm like, I don't know what the alternate segment theorem is. Like I've not thought about this for 19 years. Like
This
so
does
anyway.
this does make me feel a little bit better about my performance at the GCSE. And I'm going to tell you a little anecdote that maybe you knew at the time, but I have no idea. We sat our GCSEs with practice exams, right? So I don't know, a couple months before they
Mhm.
dragged us all into the main hall and made us do a version of it. Well, I forgot my calculator to my maths exam, and and I tried to do as well as I could. I worked it all out and
Yeah.
then left it just before the last calculation. And I remember our teacher, Miss Candola, she came over and she's like, why'd you do so bad? And I was like, well, I forgot the calculator. She's like, you didn't think to raise your hand and ask for one? I was like, oh no, I didn't.
Yeah.
So yeah,
I was
sometimes
about to say, when you
calculators.
said this, I was like, surely they've got spares. Like, there's no way in a school of like, what, a year group of 300 doing a maths exam that everybody is remembering their calculator. Like,
No, I did feel quite foolish, and I think I felt too embarrassed to
yeah.
ask. But yeah, no, that was my main memory of GCSE maths is forgetting. I did not forget the calculator for the real exam, thank goodness. So I want to
Good.
ask a little bit more, Tom, about your sort of persona that you've created on YouTube and in other forms of social media. Because as I can see, it's when you were 16, you did not have those tattoos. You did have a very similar hairstyle, I gotta say, if I remember rightly.
Yes, this is literally 16-year-old me, right? Yeah, yeah, that hasn't changed.
The same thing. But you sort of created this a persona that's not sort of what we think of when we classically think of a mathematician. And so I wonder if you could talk about that a little bit as appearing as a maths person that's not a maths person.
Yeah. Well, it's interesting you describe it as a persona because it's just me. So like it's one of those things. So I do have other personas in certain situations when I'm doing when I'm visiting I have a particular audience, then I can
Uh-huh.
kind of play up certain aspects of whether it's like I'm playing up the Oxford part of my role or whether I'm visiting, let's say, an inner city school in London and I'm like playing up the like, oh, that's I'm like one of the kids and it's all chill and like you see you kind of like play to your audience and there is a little bit
Yeah.
of like role playing or persona in those situations to get the extra engagement. But I think just the kind of like the tattoos, the piercings, the emo hairstyle from 20 years, this is just me. And I just happen, I've just never really grown out of it. In that sense, it's still a big part of my life. I listen to a lot of live music. I have tried to learn the guitar. I'm terrible at it. I enjoy tattoos. I enjoy the aesthetic, the fashion. It's just like part of my personality. So it's not necessarily that I'm choosing in a sense for that to be the persona. I think it's
Mm,
just saying, well, this is just me and who I am. I happen to also
mm,
really enjoy maths, and as you say, that's perhaps is not the expected person or the stereotypical person you think of as a mathematician, especially working at Oxford and Cambridge, very
yeah.
traditional, prestigious, very old-fashioned in some sense institutions.
Yeah.
But I think I've just been able throughout, I've just sort of been, well, this is who I am. I believe that I have the ability to do the maths. And so to me, that's all that should matter. And that's very much like the approach I take with my students. And, now that I'm able to actually like have a team that work under me, etc., I'm like, I don't care what you look like or whatever. Like if you're good at maths and you want to come in and work in shorts, flip flops, and a vest, do it. From my perspective, right? It's possibly not the best idea to teach like that, but if you're really good, I don't really care. Right? If you are the person that I want for that job and you're really good at maths and teaching or whatever the role is. So I think
Yeah.
it's something that within reason there are for example, I'm not interested in having a face tattoo, but I feel like when you get to certain extremes such as that, there are elements of it could be off-putting or possibly offensive to some people. So I
Mm,
think
mm.
it's within, I wouldn't, yeah, that was where it gets a bit more of a gray area. It's a little bit trickier when in certain situations and things. But from my perspective, yeah, I think it's just this is just who I am and me
I
and
love
sort
that.
of I'm glad that it's not something I really set out to do necessarily, but I'm very glad that I now get all of these lovely messages from people saying that they love seeing someone who is more alternative who is working at Oxford, for example, and it sort of makes them
Yeah.
think, oh, well, I'm also like an alternative, whatever, like kid at school, so that's they don't need to fit a certain mold to
Yeah.
work at one of these institutions.
And I imagine that authenticity sort of comes across in something your audience can pick up on, because if it was a persona as such, like we all do have different personas that we put on, as you've
Yeah,
mentioned, for different jobs and different roles. And I put
yeah.
my teaching persona on when I go into classrooms.
We all have the teacher voice, right? They're like,
Oh,
oh,
absolutely.
yeah.
But if it wasn't authentic to you, I don't think it would resonate as much as it
Yeah.
obviously has with the public. And I think that's
Hmm.
fantastic. And I really, really admire what you're saying about like drawing people in who wouldn't necessarily see themselves as
Hmm.
mathematicians or as academics, and sort of giving them the space to see themselves. I think of this, of course, in terms of gender. So as a
Yeah.
female professor, that then we're more common, especially in my field of psychology now than we ever have been before. But it is still a little bit unusual. No, our default for a professor is an older man that doesn't have tattoos. And
Yeah.
and so I see some similarities here with sort of opening the doors to people to see themselves in academia that wouldn't necessarily see themselves there.
Hmm. Yeah. I think it's just the way I often think about it is the of the people who do maths and are mathematicians and are interested in maths, there is no specific reason why they need to look or behave in a certain way beyond enjoying maths. So if you just sort of take that approach and kind of just filter it down, that means in theory you should get a really good cross section of just humans. Of course, it doesn't quite work like that given opportunity, etc. So obviously it's
Mm.
very like kind of, Western focused and things of that nature, particularly obviously in Europe and the US. And like, so there are other things that feed into it. But just in terms of like hobbies, interests, that kind of thing, I think generally if you sort of take that mindset of, ideally there should be pretty much the same sort of spread of personalities, styles, appearances within any job than as there is in the population in general. If everything is working well in terms of equal opportunity for people, which of course is a whole other thing, but I think that's sort of how I try to think about it and make sense of it is that there is, historically perhaps that equal opportunity wasn't there at all. It was
Mm.
very much for an elite group, a select group. And that's why we have these outdated, as you say, it's an old white dude, right? When you're thinking of a professor. So that's like a historical thing. But I think now in most societies and countries and systems, we are a lot more progressive and open to the fact that giving opportunities to underrepresented groups because they are just as good as everybody else when they're given that opportunity. And so with that mindset, it's less surprising that you get, a bit of everything in that sense.
Yeah, fantastic. So you can embrace your tattoos, and you can't see them here, but I have a fabulous set. I'm going to show them to the camera. A fabulous set of shoes today. My
Oh, wow.
students
Yeah.
know I love my stilettos, so I'll keep wearing them, and you keep doing your tattoos, and it'll be all right. I want to talk a little bit about what I've put in my notes here as the psychology of maths, but it's probably we have a wonderful colleague of mine who actually studies math anxiety as her topic. So she's going to judge me for how oversimplified I'm going to make this. But the people do often have anxieties and fears around maths that come really quite young in school ages, and then the idea of, oh well, Oxford maths, like that's just must be far too difficult for me. So how do you help people to sort of get over those anxieties or reframe those anxieties in your work?
Yeah, that's a tricky one, right? That's often the main battle that I'm fighting when I'm trying to reach people who have this negative association with the subject. And a lot of the people that I talk to, and I'm sure this is probably the same over in the US as well, is they almost like wear it as a badge of honor, the fact that
Mm.
they don't like or cannot do maths, which is really weird because no one does it for any other subject at all. But it's like when I say I'm a mathematician and they go, "Oh, I can't do maths, don't like maths, not for me." Can you just imagine saying to somebody like, "Oh yeah, I do English. Oh, I can't do English. Not for me. I can't speak the language." Like, it sounds ridiculous because it kind of is, but weirdly, for some reason, as like a society, we seem to be okay with like saying we don't like maths. So I think first of all, it's not. I don't want anyone to be ashamed that they can't do maths, but it's just interesting that their go-to is to admit that they can't do it or that it's not for them. And I think a lot of that, as you say, is rooted in this idea of like of maths anxiety having a negative experience with the subject when they're learning it at school. I think a lot of that comes from the fact that maths is very much is like a pyramid. So it's like
Mm.
if you if you miss out and you can't get your head around fractions and algebra, you have no hope because if you can't do like the lower level, not that that's super
Mm.
low level, but if you can't do that, you've got no chance of being able to do anything, beyond like age sort of 12, 13. If you're struggling with that. And by that point, the system is set up, especially in schools when, teachers have all of the things they have to teach you for an exam. They can't really like give you that focused learning that you need to get your head around manipulations of fractions, algebra, solving for X. If that's something you struggle with, and you never kind of get over that struggle, I can't even begin to think how difficult it would be to do like anything beyond, age 12, 13, 14. And so I think a lot of it is that it's because you get stuck at a point, and if you don't fill in that gap, you can maybe get a little bit higher up. But again, you'll sort of imagine building like your pyramid or your Jenga tower with bits missing. That's just how
Yeah.
maths works as a subject. It's
I'm now
not
wondering about
as
like the anecdote I told you at the beginning about feeling like I got to my edge of my limit of what I could understand about maths. So maybe it was just that actually I'd spent a bit too much time that year not concentrating in class and had too many holes
we're just
in my
missing
math
a few
knowledge
bricks.
at that
Yeah.
point that now I couldn't build on it anymore because I'd sort of lost a few critical parts on the way through. Man, now I'm feeling like I should have powered through. Or I guess what you're saying is
Already
it's gone
inspired.
back
Yeah.
and like tried to it's hard though, I suppose, as the person who's studying maths to identify where those holes are. And
Of
without, a
course.
really good
Yeah.
teacher pointing out
Yeah,
where
yeah,
the
yeah,
holes
yeah.
in your knowledge are, it's difficult, man.
But I think that's the reason why a lot of people end up struggling with the subject anyway. Just because maths, for example, if you're doing history, right, and you're like, okay, so there are core skills, like reading, referencing, summarizing, forming opinions. But if you're studying like, I don't know, you're studying the American West 1 month and you're not really concentrating, you're having a bit of a bad time, whatever, you're not paying attention, you're absent. And then you come back and a few months later, now we're doing like, I don't know, Nazi Germany, for example. Like, you're like, oh, cool. So we're jumping to a new topic. You can come in and you can kind of
Mm,
start afresh. And again, as long as you've got the core skills, it doesn't matter that you kind of missed a bit. But if you
yeah,
miss the lesson when we do fractions, and then later on we're doing algebra, and you're like, whoa, I've got like x divided by like y, what's going on? Like, because you're missing the fraction bit. So I think it's
yeah,
just the nature of the subject, I think, means people get lost and have those holes, as you say. So I think that's what it leads to. How do I approach it? I haven't even answered your actual
yeah.
question.
No, no, tell me the solutions. Yeah.
Yes. Okay. So the way I think about it is when I have a particular person or audience, I have to bring maths, my thing, to their playing field, to their arena. So if I'm talking to, I don't know, a 15-year-old kid in an inner city London school, right? And he plays football, he's really good at football. So I'm like, right,
Soccer.
let's talk penalty kicks. Let's talk, yeah, soccer. Let's talk, right? Let's talk about, ask him about if he's taking a penalty, where does he aim? Where does he aim the ball in
Mm,
the goal? And then from that, you can then turn it into, well, it's actually a geometry problem, isn't it? Because you're trying to hit your circular target within the rectangular goal. The goalkeeper is kind of diving and covering a semicircle. So suddenly you're talking about shapes. Suddenly you're
yeah.
talking about geometry. I have a whole talk where we figure out where is the perfect place to aim that shot to maximize your chance of scoring, which of course they might not follow the maths, but they want to know the answer. And so I've kind of got them hooked, right? You've kind of got them
Yeah.
in by being like, oh, I'm going to tell you, like, how do we figure out how to take really good penalties? How do we figure out to, another one I talk about a lot is to do with the Earth's rotation and its impact on rowing. So like very Oxford, Cambridge, like rowing on the river. Um, and you can look at the impact that the Earth's rotation has on these events. And basically, if you, in theory, you can go 8% faster at the equator than you can in, let's say, the UK. Um, and again, if I'm talking to an audience of people who are interested in rowing, like I did this talk at the local rowing club, which was a whole range of different age groups, immediately they wanted to know, well, that can't be true. I don't believe you. Show me why. And then, I did like an hour-long maths lecture because they wanted to understand where this number had come from and how it worked.
Oh,
So I'm
right. So
not
it's,
going in and saying, I'm going to do maths, because then immediately they'll turn their brain off, right? That's like the
mhm.
trigger of them being like, nope, nope, that's the thing I don't like. They turn off. But I'm like, you're interested in sport, you're interested in video games, you're interested in, oh, I don't know, whatever else, movies. I don't know, Maths to Jurassic Park, you're into dinosaurs. Let's do some cool stuff about size of dinosaurs, which was the fastest dinosaur that ever lived. I did a video about that. So it's like, it's taking the maths, but bringing it to the thing your audience is already interested in. So that
Right.
rather than telling them we're going to do maths, because then they're just going to switch to the panic mode that they remember
Yeah.
from school.
I can resonate with that a lot. So I teach psychology, obviously, and so although I say I'm not a maths person, psychology is an awful lot of statistics, and so we do a lot
Yeah,
of maths in that sense. And so a lot of students, they come into psychology, they want to think about how people interact, they want to know about mental health, and that's where their
yeah,
interest lies. And then we do kind of hook them with that and then tell them, oh, I'm sorry, you've got to do 3 or 4 mandatory statistics classes in order to get this degree. And that comes as a big shock to a lot of students. And they do
yeah.
it because they're interested in the people. But you're making me think that when I'm teaching this, I need to do an even better job of connecting. Okay, you want to know this about people. We need to do this statistic in order to know whether this is true
It's
about people.
yeah, it's sort of like there will be something, and you'll know what this is obviously much better than I will, but there'll be some like piece of information or some question you want to ask about something. So maybe you've got 2 patients, or I don't know, and you want to like compare them in some way, or you want to have some way of measuring, oh, but where are they on such and such a scale of such and such an illness? And again, like, so you're wanting to, you kind of paint that picture of being like, okay, well, it'd be great if we had a way of measuring and quantifying this. Right.
Right.
Here's where we need some numbers, we need some equations, we got to do the stats, the maths. So it's kind of, you just set them up in, you can, and this doesn't work, as you said, in a more general context of, well, you've got to do this to get your degree, or you've got to do this to become qualified, or whatever they, right? And so that can work, but if that's not quite enough, then you kind of, yeah, you can kind of granulate it a little bit more into like paint, tell them a story, create a situation where they want to figure out between 2 choices. And the only way to figure out between those 2 choices is to do the maths and the statistics. And then they want to know,
Right.
they're like, oh no, I really want to know the answer. So they
Yeah,
actually are
I mean,
almost like,
honestly,
please
that's
tell
the
me the
reason I
maths.
do it.
Yeah.
Oh, I'll sit there and crunch data for
Yeah.
hours because I want to know the answer
Yeah.
at the end of it. Yeah,
Yeah. Yeah.
absolutely.
Yeah. Yeah.
Um, all right, I want to shift gears a little bit now and talk a little bit about technology and communication. So I was really I love following you on Instagram because I'm like, oh well, there's these 2 random people from Bridgewater High that are both doing like public scholarship and so I have felt a great affinity. Obviously I love to do this podcast, and you have your incredible social media and YouTube following. And so I just want to talk a little bit about how you use, especially YouTube, to sort of connect. We talked about a little bit earlier about your Turkish following, but how you see the benefits of technology that allow us to get out of the classroom and connect with other people.
I think it's exactly that. I think it's the global reach, and it's something that I've been working on a lot now in the Oxford Lifelong Learning department where I'm now based, because we, for example, are offering, we offer like 500 courses taught by Oxford academics in every possible discipline you could think of. Like it's like a university within a university. But when I joined 2 years ago, the majority of those were in person in Oxford, which is great
Mm.
if you are close to Oxford or can travel to Oxford. But if you're doing a weekly class, it's quite tricky if you don't live in Oxford. So it's sort of, I think it's just that in a nutshell. So, I've been working with the department here, my role here, to be like, well, why don't we offer these online? Right? Let's obviously we have to make sure we record good quality and interesting lectures, which is then where my experience with YouTube comes from. But
Right.
that's how you reach that global audience. That's how you bring everyone else in. Because, again, the whole point of lifelong learning and, or extension schools is to literally extend the university to that wider audience of people who can't come in and do the standard degrees, who have
Yeah.
jobs or who are based all around the world. So I think that's also the power of YouTube, I think, or social media generally, is that you can reach so many people in all of these places. So for me, that's my some of my favorite comments that I get on my YouTube videos. I often a lot of my good video ideas come from questions and problems my students can't do. So, they'll turn up, we're doing our class on linear algebra, and something happened. I got fed up with this happening every year. The students would come in and they'd be like, okay, so, I'd say, right, what did you do in lectures this week? And they'd be like, okay, we did the spectral theorem. It's like a maths thing. And it's really difficult to prove, right? It's a really important result, but the proof is hard. Like, even to me, it's hard. And I teach it. So every year, sorry, I would just repeat this same sort of class like 3 or 4 times to every set of students of like going
Mm.
over how I try to eventually get my head around this proof. And then I realized, well, if my students, who are fortunately some of the brightest kids in the world, are stuck on this, then so is everyone else. So I ended up like just recording a 1 hour video, with my blackboard of me going through what I felt was as intuitive an approach to the proof as I could give. And now, fortunately, the students come up and they say, so we had the proof in the lecture and we didn't get it, but then we watched your video and now it's okay. And all the comments underneath are people, people in Brazil, people in India, people in Thailand commenting and being like, didn't get this from my lecture. Now I've watched your video. It makes more sense. Thank you so much. And
That's
so I think
fantastic.
that yeah, they're amazing to read, but I think that highlights like that's the perfect example of like the power and the really good stuff that can happen with social media and YouTube in particular for that long video. It's a 1 hour maths lecture. That's not going to work on Instagram or TikTok, but for YouTube, it's perfect for those people who are using it as a source of learning and they have access to, what hopefully, from what my students tell me, is my good explanation of this difficult thing to help them with their own studies and their own degree. So I think that's kind of like the power of it and that global reach is one thing. And then the other thing, and I'll keep this one short because I'm talking too much, is similar to what I was saying about bringing maths to the arena of the audience and what they're interested in.
Mm.
For better or for worse, the world now spends its time on social media. And so again, it's like taking the educational content, in my case, maths, in your case, psychology, and bringing it to the medium that the audience are engaging with. So again,
Right.
I think it works for that, but also that's, because that's what people spend time on. I think you as an educator, communicator, obviously have to, again, bring it to the platform that people are using and
Right.
embrace that.
Yeah, no, that's a great point. And actually, when you're scrolling through social media, right, and you've got some cute kittens, and then some doom and news and the terror, and then some more cute kittens, and then you've got a cute little maths video that's a little bit of education comes in. It's
Yeah.
makes a nice. We talk about diet and eating the rainbow. Maybe we want our media diet needs to be a little bit more spread out as well. Maybe that's the
100%. Yeah,
the
yeah,
space
yeah, yeah.
to go. I do want to ask you though, because so an hour-long maths video sounds kind of scary from someone who doesn't generally watch hour-long maths videos. So is it just you at a board, or like what do you do to keep people watching the whole thing, or do
It's
you
it's
expect
me at
them
the
to fast
board.
forward?
It's okay. So that one is just me at the board. I think that one is very specific because that is, the people that are watching that, and they see a spike every year around sort of like October, November time, because it's taught quite early in the year in any linear algebra course at any university around the world. So that's like people searching proof of spectral theorem, on Google, which is the company that owns YouTube. So obviously, right, there's a big connection there. YouTube is the world's second biggest search engine after Google. So, right, so that's kind of how that happens. But what I will say with, so I think I already have the engaged audience for that type of
Right.
video.
Okay.
But then the exam videos, so some of these are 2.5 or 3 hours long of me solving, because some of these exams are really hard, right? The Turkey one was like 2 hours. The GCSE one, so the GCSE maths one, the exam obviously we took when we were 16. So I think that video is an hour and a half, and I think it has almost 2 million views. And it's literally me doing a maths exam, right? I have half of my screen is a screen recording on my iPad because I'm writing so people can see what I'm writing. And the other half is just me talking to the camera like this. So, and addressing the audience. So obviously I'm explaining my thinking, right? I'm saying, oh, okay, so this is a probability question. It wants us to figure out this. Okay, so this is such and such a distribution. Like I'm talking through as though I'm teaching as well as trying to answer it. But that's it. And it's like an hour and a half. Almost 2 million people have watched it. I don't know why. I wish I knew. But I
I
don't
think
know.
it's definitely a call for the just wanting to see someone who was as well educated in mathematics as you from such a
Yeah,
prestigious
yeah, yeah.
institution and be like, yeah, he finds it hard too. Whew, it's just
Yes.
such an emotional relief to feel better about yourself if you're studying for your own exams or you've just taken them.
Yes. I definitely had a few teachers who sort of send me these lovely messages saying, first of all, they love the videos because they're like, it's the only homework they can get their students to do. They're like, your homework is go watch a 2 hour YouTube video. And they're like, and they actually do it apparently as revision. But also saying that they appreciate I don't think it's brave, but they think it's brave that I just sort of do this and show the kind of the fact that I'm not opening the paper and just immediately knowing the answer. Um, but again, I think that is unfortunately the image that lots of people have about mathematicians,
Mm,
right? Is this kind of genius, right, type thing. And you get all these really annoying problems, usually on Facebook, where it's like, only genius can solve. And it's like, no, stop this nonsense. It's
no,
it's nothing to do
you're
with being, yeah, it's a human process. It's just like any other subject. You read the thing, you might know what to do if you've spent a lot of time doing maths like I have, but also I read some things and I'm like, well, I don't know. Let's play around. Let's draw some stuff. Let's try things.
yeah.
Let's poke the problem and see what happens.
I love
That's how I
that.
think about it.
Yeah, no, I mean, and I was talking earlier about, breaking down stereotypes and not appearing like a traditional mathematician. I was thinking mostly aesthetics, but you're absolutely right. The idea of admitting when we're wrong and showing that we're human. I have this bit in my syllabus that says something like, I'll give you grace if you mess up, if you give me grace when I mess up, because, we
Yeah,
do mess up
yeah,
as well.
exactly.
And showing that human side, I think, can only be good for both sides of the relationship. It'll help our students to
Hmm.
see that we're fallible and for a good humbling reminder for ourselves that we don't necessarily know everything, despite what we might sometimes like to show people.
Hmm. Yeah.
I have one last question that I'm going to finish with, which is completely off topic for this podcast, and the editing may choose to take it out. But this is purely for my own curiosity here. So I looked at what your PhD was in, and you can correct me if I'm wrong here, but it's how river water mixes as it enters the ocean. Is that right?
That is correct. Yes.
All right.
Very
Okay.
good.
So here's my question. So up here in Green Bay, we have the Fox River, which flows into
Hmm.
Lake Michigan. So two things there. Lake Michigan obviously isn't an ocean, but also the Fox River is known to flow north as opposed to,
Hmm.
I believe, most rivers flow south. So how would that change it? Or does it change it? Or is it the same as when it goes into a lake as whether it goes into the ocean? Or basically, I just want all of your insights now.
Okay. So the main impact on river outflows is actually the Earth's rotation. And this is how I ended up doing the whole thing about rowing I mentioned
Oh,
earlier.
yeah. Okay.
So basically, in anywhere in the northern hemisphere, the way that we model this, it's I'll give you the names, but I won't explain the detail because it's complicated. But it's something called the F-plane approximation. And basically, it allows you to analyze the river mouth, whether it's into an ocean or a lake, doesn't actually matter. And what you're looking at is then the sort of conservation of angular momentum. So the Earth's rotating, the water's coming in. In the northern hemisphere, what's going to happen is it will turn to the right. And that is independent of the direction of flow. So whether it's going north, south, east, west, don't care. That's why we talk about to the right. So you're sailing along your boat, you reach the lake, turn to the right. So that's what's going to happen because of the Earth's rotation. Now, there are other impacts. So if there are like local tides in the ocean, whether there are currents in the lake, whether there's a really strong wind, that can obviously, like, all of these effects can compound and fight against one another or strengthen. But just in terms of the Earth's rotation, the river water will flow into the lake and then it will go to the right and it will hug the bank of the lake generally.
Oh,
so that's what you're going to see. So if, and in the southern hemisphere, it goes left. It flips as you cross the equator. And you see that because the function you use is the sine function from trigonometry, sine.
Which I remember from being
latitude.
a button on my calculator.
Yes, yeah, sine of the latitude. So the equator's at 0, and then as you go to the north, it's positive, and as you go below the equator and south, it's negative. So sine of a positive angle is a positive number. Picture an x-axis in front of you. Which direction do you move if you're going positive? To the right.
To the right. Okay, yeah.
So you turn right.
Everything's going to be flipped on the camera now.
Yeah. And then if you've got sine of a slightly negative angle, so I don't know if you ever, I don't think we study this at GCSE, but if you do sine of minus 30 degrees, let's say on your calculator, you'll get minus a half. So you get a negative number, the sine of a negative angle. So negative means move left. So in the southern hemisphere, it moves left. So that's like a really helpful thing to know. So obviously you can go into more detail, and obviously my whole thesis was like, well, how big are these currents, how deep, etc. But just in like a basic level, it's telling you that if there is any pollution in your river, big if, I don't know how polluted the Fox River is or is not, but if there is, it's going to come in and turn to the right and then hug the bank.
Yeah,
as
so
it goes
it's going to
around.
go down to Chicago. That's where it's heading then, out of our...
Yeah, okay, well, there you go. Yeah, so if anything you dump into the Fox River is ended up in Chicago, so make of that information what you will.
Yeah, it's got to go, well, we got a peninsula, so it's got to go around a peninsula first, but
yeah.
You know, I'll have to send you a map and you can draw out where
Yes, and that's what I do actually when I do this talk in schools or events. I actually take the local river and draw a map and show them where the river water and therefore the pollution is going to go, because you know it tells you two things. It tells you if you want to do good and go and like clean up your local beach or river or lake, then that tells you where you can go and you're going to find the rubbish, so you can maximize the time you're spending on that cleanup operation. Or if you want to go swimming, it tells you where not to go swimming, so you avoid the area.
Fantastic. Well, we have a wonderful conservation psychologist on staff here who I will immediately be walking back into my department and telling her this information to see if she already knew it, which she might. Thank you for satisfying my curiosity there. And another example of how we are interested in math when it's relevant to something that we want to know. Exactly that. Yeah. Well, thank you again so much, Tom, for joining me on the podcast today. I really appreciate it. And I never thought I'd be on a podcast with someone from Bridgewater. I never thought I'd be hosting a podcast. But I definitely never thought that this would be the interaction. So it's great to see you, and thank you so much.
My pleasure.
Psychology and Stuff is brought to you by Good Cause Productions at the University of Wisconsin, Green Bay. The executive producer is Ryan Martin. The production manager is Rachel Sankey, and our creative director is Jenny Young. The media engineer for this episode is Kennedy Punke, supported by our production manager, Rachel Sankey. Special thanks to my guest today, Dr. Tom Crawford. If you haven't already, please make sure to rate, review, and subscribe to us on your favourite podcast platform. I'm your host, Alison Jane Martingano. Keep being amazing.